when we have a graph and we're trying to find the equation, and this one in particular says in terms of sine x. Technically, we're going to find out when we find this equation, there are an infinite amount of right answers. There's an infinite amount of right answers that you can write for this equation. And for every graph that you have, if it's a sine graph or a cos graph, you can find an equation for both. Because this could be a sine graph or it could be a cos graph, because they're just translations of each other. So how do we find one of those infinite right answers? Well, we have to do the same sort of undo what we would have done to graph it. Remember when we graphed it, we used the technique of DAB-C? So we're going to sort of think about that again. If we were graphing this, what would D be? It would be 1, because 1 is your center line. How do we know that it's... Right, we can check how far is this line away from the maximum. It's a distance of 5 from the maximum. It's also a distance of 5 from the minimum, so we know that that's right in the middle. Now, when we talked about our center line, we gave it some other names. I also called it the sinusoidal axis. I said sometimes we just call it the average. Now, if you think average, that's a nice way to figure it out as well, because you can take your maximum, which is 6, your minimum, which is -4, and what's the average between 6 and -4? Well, if you think, how would you do an average if you got like 60 on one test and 80 on another test? You'd add them up and divide by 2 and find out your average was 70. Same thing here. We can add up 6 plus -4 is 2, divided by 2, and we get our center line at y equals 1. Our a value would be the next thing that we would put on our graph. If we were graphing this, we'd use our a value, which is our amplitude. In this case, what is our amplitude? It's equal to 5. When we talk about our amplitude, it's always going to be positive, because it's the distance from the middle to the maximum. Sometimes in the equation, you get a negative in front depending on your starting point, whether it's been flipped over or not.
But wouldn't a flipped over one just be, if you're translating that?
What's going to happen when we write our equation out, we'll decide whether to put a negative there or not. Okay? Because that's one of the options you have and why there's an infinite amount of answers.
That's why it must be hard to mark these.
Well, you get pretty good at them, so not too bad. And for b, your b, when we had a b value in our equation, it helped us find our period. So in this case, though, we have the equation. Can you tell from the graph what is the period of this function? 2 pi over 3. So a couple of ways you might have seen that it was 2 pi over 3. Okay. One, if we go from this minimum to this minimum, that distance right there is your period. So if you were counting things and you wanted to count how far it is across from there, you'd go 1, 2, 3, 4, 5, 6, 7, 8. Great. I now know that it's 8 sections over. In order to figure out how long 8 sections is, we need to know what one section is. Can you see that one section from 0 to here would be half of pi over 6? So that would be pi over 12. So one way to figure out the period, now that we've counted 8 between those two minimum points, is that it would be 8 pi over 12s. And that reduces to 2 pi over 3. Now, probably some of you used other techniques. You just said, well, this is the distance of one period. If I move it back to 0, I can see that it goes from 0 to 2 pi over 3. Because this distance from one minimum to another is going to be the same from the center to the center. So if I move that back starting at 0, which moves this one back 1, which would move that one back 1, I can see that my period is 2 pi over 3. See that basic idea? I guess we could also show it by just moving it back 1 here. So your period is 2 pi over 3. That still doesn't tell us what our b value is. Now, we had a couple formulas, right? Because your b value is going to be a stretch or compression horizontally. In this case, it's going to be a horizontal compression. We have this formula that your period was 2 pi over your b value. We rearrange that formula to say that our b value is 2 pi over our period. So there's two ways that you can find out that your b value is 3. You can use this second formula, which already has b by itself. And then, in this case, you would say, well, b is equal to 2 pi divided by my period, and my period is 2 pi over 3. How do I divide by a fraction? I multiply by the reciprocal. And the 2 pi's nicely cancel out, and I get b is equal to 3. So that's one way that we could figure out that b is equal to 3. The other way to figure out that b is equal to 3 is to say, if I know my period is 2 pi over 3, and my formula says period is 2 pi over b, just by observation you can say, well, the b must be 3. And so that's another way that you could figure out that your b value is 3. Now, in all of these equations, woo, that's fancy. In all of these equations, when you go to write your final equation, you really just need your a, your b, your d, your a, and your b to start. And the c is the only thing that can change that can make us have an infinite amount of answers. So what you'll do is once you figured out d, a, and b, you'll start writing your equation. So I know that my a value is 5. I need it in terms of sine. I know that my b value is 3. I'm going to leave space for my c value, and my d value is plus 1. So we can start like this. Now, where does a sine graph start? It starts in the middle, going up. So we need to look at our graph and say, where can I find that point? In the middle, going up. Can you see that there's one right there? Is there any more on the graph? Yes, there's another one right here. And if we kept on going, there'd be a whole bunch of them. So option 1, let's choose the first one. Well, normally it would have started in the middle going up right here. But can you see that it's been translated 3 sections to the right? How much is each section? Each section was pi over 12. So it has been shifted 3 pi over 12s to the right. How do we write that? Plus or minus in here? Minus to go to the right, minus 3 pi over 12. Of course, you could reduce that to pi over 4, but you do not have to. That's option 1. How about option 2? Again, the dab part stays the same. What if I chose the second one? Then it's shifted to the right. How many? Has anyone counted it out already? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you could have also shifted it 11 pi over 12 to the right. Right? If you really want to frustrate me on an exam, you can go about 3 miles to the right and find a right value and write it in. Right? I might just mark it wrong, and then when you get it back, I say, well, prove to me that it works, and then you have to do all the work to figure it out. No. And we could also do a negative sine graph. So if you chose a negative sine graph, where does a negative sine graph start? In the middle, going down. So we could have, there's that point there. There's also in the middle going down right there. So those would be negative sine graphs. So when you go to write it out, again, the A, the B, I'll write 2 of them right away. Now for the first one, it's 1 mark to the left. So I could show that by having plus pi over 12. And for the second red one, if we count it, 1, 2, 3, 4, 5, 6, 7 sections to the right, minus 7 pi over 12. So all 4 of those answers are right. And if you were asked to write this equation in terms of sine on a test, you just have to provide one of those. Usually people choose a positive one. Usually people choose the positive one the closest to your y-axis as possible so you don't have to count as much. What would happen if I would have changed this question and said in terms of cos instead of in terms of sine? Well, can you see that if I say cos, has my center line changed? Has my amplitude changed? Period changed? None of those things, the D, the A, and the B, they don't change. So we can, and we'll just write one of them, so this is going to still be 5. Instead of sine, we could write cos. We still have a 3 here. Still have a plus 1 at the end. The only thing that's going to change is where does it start? Where does a cos graph start? At a maximum, right there. That's 1, 2, 3, 4, 5 sections to the right. So I could write minus 5 pi over 12. And so all 4 of these equations that we've written are exactly the same. They mean the same thing. You could also do some negative cos graphs if you wanted and started at the minimum. So we're going to practice some of these ones where we have to write the equation. So the questions are numbers 4, 5, 6, and 7.